Hello. Today I want to discuss different types of symmetry in graphs. We're going to use examples to motivate these different types of symmetry, and the point is to get comfortable with the symmetry so that we can recognize it when we see it in the graphs that we look at in the future. So we're going to look at three types of symmetry. For each of these, we're going to start by sketching a graph, and then we're going to talk about the symmetry, what it means, and how to test for the symmetry. So let's start with a graph y equals x squared. Now, we have already seen the graph of y equals x squared. It's the very first parabola that we graphed. So what I'm going to do is I'm just going to sketch the graph very quickly. Instead of going through the process very slowly of making a table of values, I'm just going to draw this graph because I don't want to spend too much time on it. All right, this is a parabola. The vertex is the origin. It's opening upward. This one is better to graph with a table of values, honestly, because if we tried to use the method of the intercepts and the vertex, all of them are the origin, and so we definitely need some more points. So there is the graph y equals x squared, and this graph exhibits a very particular type of symmetry. This graph is symmetric about the y-axis. And I will draw in a little dashed line for the axis of symmetry. I'm going to do it in blue instead of black so that you can kind of see it a little bit better. Hopefully that helps. So this is symmetric about the y-axis. And what this means is that the left-hand side is a mirror image of the right-hand side. We can also say that if we reflected the graph across the y-axis, if we switched the left and right-hand sides, we would end up with the same graph. So we can say the graph is unchanged when reflected about the y-axis. Now, there are a couple of ways that we can discuss this algebraically. One thing to notice is if we have a point on the graph with coordinates x, comma, y, its mirror image also has to be on the graph, and that'll have coordinates negative x, comma, y. So what we can say is that if the point x, comma, y is included, so is the point negative x, comma, y. And there is a test that we can use if we want to know if a graph is symmetric about the y-axis, but we don't want to actually go through the process of graphing it. There's a test that we can use with the equation to see if it exhibits this symmetry. And the test is as follows. We replace x with the opposite of x in the equation, and what we do is once we've done that, we check to see if the new equation is equivalent to the original one. So the original one is y equals x squared. If we replace x with the opposite of x, we get y equals the opposite of x squared, or negative x squared, and negative x times negative x, the x's cancel, the negatives cancel, and we end up with x squared. So this becomes y equals x squared, which is exactly what we had to begin with. So when that happens, we know that it's symmetric about the y-axis. Let's look at one more quick example of a graph that's symmetric about the y-axis. Let's take a look at y equals -3. All right, y equals -3 is a constant function. No matter what the value of x is, we know that y has to be -3. So if x is 0, y is -3. That gives us this point. If x is 5, y is -3. If x is 10, y is -3. If x is -3, y is -3. This ends up giving us a horizontal line. Excuse me. I'm curious how the closed caption will translate my sneeze. That's why I'm going to leave the sneeze in so we can check later. Anyways, y equals -3 gives us the graph of a horizontal line. And if you look at this horizontal line and we reflect it about the y-axis, we can see that the right and left-hand sides are mirror images of each other, and so we know that this exhibits symmetry about the y-axis. If you wanted to do the test replacing x with -x, we've got y equals -3. There is no x to replace with -x, so if we do that, if we rewrite this equation and change any x's to -x's, we still have y equals -3, which is equivalent to the original one. So this is another example of a graph that is symmetric about the y-axis. We're going to have 2 more videos in this section, and each of these videos will talk about 2 other types of symmetry.